Taking a look at some of the main ideas of trig, we can look at a trig, the shape of a right triangle, from two different perspectives. One of them is using an angle. For example, 30 degrees gives us an idea of the shape. Or the other way we can describe the shape of a triangle is through a ratio. Okay, so if I said the opposite to hypotenuse side was 1 to 2, it will give you an idea of what the shape of that triangle is. Now these are two very different ways to describe the shape of a triangle, and to be able to convert from one to the other, it's very hard unless we have one of the two special triangles. Otherwise, we need to use a calculator to be able to convert a ratio to the angle form of that shape, or the angle form of the shape into a ratio form of that shape. When we talk about the ratios, the trig ratios are specific ratios, and these specific ratios have names. So when we talk about the sine ratio, we are talking specifically about comparing the opposite side to the hypotenuse. And we can't mix up these different ratios. So when we talk about sine, our calculator knows that we're comparing this side to this side, and that ratio is going to give us the shape. For the cosine ratio, we can use the adjacent side. We're going to compare the adjacent side to the hypotenuse. Okay, so the cosine is specifically then comparing this side to this side. And the tan ratio is going to be the slope ratio, which is rise over run, or opposite over adjacent. Okay, and it's important to recognize that the tan really is the rise over run, or slope. It's the same as slope. And so we can use also SOHCAHTOA to help us remember, because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, ka, and toa is tan, opposite over adjacent. So we need to be able to convert from angles to ratios, ratios to angles, and recognize when we're going to use either the sine or the inverse sine function. So when we have the angle, we're going to use the sine button on our calculator to calculate the ratio. So we end up with a ratio of 0.438. Okay, so what that means is sine is the opposite of our hypotenuse, so the opposite side is about 43% the length of the hypotenuse, and that gives us a shape, angle shape of 26 degrees. Here we have the inverse tan, so the input of the inverse function is the ratio, so the slope is 2/7. The inverse tan will give us the angle. Okay, so I'm going to type it in just like it is. And that's going to give us the shape, the slope of 2, rise of 2, run of 7 gives me an angle of about 15.9 degrees. So I'm going to round that to 9.5. It's 945, so I'm going to round that to 9.5. So notice I use 3 decimals for the ratio, 2 decimals for an angle. Okay, and I'm going to put the angle in there. Here the cosine theta is equal to the ratio 0.892. Well, this is a ratio. We need to figure out the angle. That's the same as this problem here. We need to use the inverse. So although it's written with cosine, we need to recognize that this is going from ratio to angle. And to do that, we need to use the inverse function. So inverse cosine of 0.892. So if the adjacent side is about 90% the length of the hypotenuse, the angle that we're talking about is 26.874. So I'm going to round that to 87 degrees. Here, the inverse sine gives us an angle of 67 degrees. Okay, so when we do inverse sine, we get the angle. We want to know the ratio. Okay, so if we want to know the ratio, we have to write it in the ratio form of sine of 67 degrees equals the ratio x. Here we're just going to type in sine 67, and we get the ratio of opposite to hypotenuse of 92.1%. Okay, about 0.9205, so I'm going to round that to 0.921. So that means that in 67 degrees, this length here is about 97% the length of the hypotenuse, and that's what we would expect for that angle of 67 degrees. Just write that a little bit neater there, 0.921. So we also need to be able to use some expressions or variables that express the ratios. Okay, so in this case here, we're not going to be able to solve for the angle because we don't really know the numerical values of these, so we can't really determine the shape. So we can't really convert from shape to ratio shape to angle shape. But we can write these expressions as algebraic expressions. So when we talk about the sine ratio, we're talking about the opposite. So opposite and hypotenuse. The hypotenuse here is 23, so we end up with the expression x minus 2 over 23 as a ratio. Okay, and this is just the ratio of the algebraic way to write opposite over hypotenuse. Okay. Cosine is the adjacent over hypotenuse. Cos is cosine. So adjacent over hypotenuse is the cosine ratio. So I look for the expression that shows me the adjacent side. The adjacent side is A. Adjacent means next to, and it's not the hypotenuse. The hypotenuse is always just the hypotenuse. Divided by the hypotenuse. In this case, we do know the numerical value of the hypotenuse is 23. And then lastly, if we're going to write the tan ratio, we want slope. We want opposite over adjacent. Rise over run. So the opposite over adjacent, rise over run, is x minus 2 over the adjacent side, which we labeled as A. Okay, and specifically in that order, opposite hypotenuse, not hypotenuse over opposite. Okay, we have to make sure we have it in the right order, right number in the numerator and the right number in the denominator.